Okay, what we're going to do is we're going to go ahead and kick off the panel. We have a truly incredible group of leaders like across the industry here, from practitioners who are deploying models into production, to researchers, to leaders at hyperscalers and partners in the ecosystem. So what I'd love for us to be able to do is, Travis, perhaps you could start with just an introduction for each, and then Travis will be moderating the panel, and I'm really looking forward to some of the questions and answers that are asked here. So over to you, Travis.
Thanks, Dev. Hi, everyone. I'm Travis, co-founder and CTO of Predibase. Also worked on the Lorax project, Horovod project. It's great to be here moderating this panel with a great guest of folks. Rajni, so I'll hand the microphone over to you to kick us off.
Hi, everyone. I'm Rajneesh Singh. I'm very excited to be here. I lead the SageMaker training group within AWS. Some of you may know SageMaker is a machine learning platform offered by AWS to help customers prepare data, train machine learning models, and deploy machine learning models. And SageMaker not only does it for classical ML models, but even for generative AI models. So I've been with SageMaker for roughly around 3.5 years. It has been a fantastic ride to see how classical ML was shaped up, and now generative AI is shaping up the future. So very excited to be here, and looking forward to this talk.
Hi, everyone. This is Akshay here. I lead engineering at ConverseNow.ai. ConverseNow is a voice AI company. We build voice AI products for food technology, especially for restaurants. Like you'd go to a drive-through and you'd place an order. You'd interact with our AI system. It systematically processes it, pushes the order through into the system. Similarly, you might call a store or a restaurant, and our system basically takes the orders. We were founded back in 2018. I was one of their first engineers, founder without all the liability, basically. And we basically started off with traditional NLU technologies and eventually moved on to a generative AI platform. And now we are expanding into sort of trying to figure out not just voice AI, but how can we use generative AI for all sorts of agentic AI stuff that could be useful in the restaurant domain and the restaurant industry in general. That's what I'll hopefully give some insight in this session.
Hello, everyone. My name is Pavlo. I'm a research director at Nvidia. Working primarily on small language models and efficiency in large language models, things like compression, distillation. Our main focus, working also on alternative architectures. Those, let's say, that going to have Mamba for better efficiency. We also work on reasoning and vision language models research, like building state-of-the-art things. Thanks.
Hey, everyone. Terrence here, partner engineer at Meta, focusing on Llama. So our role at Meta, we help with the Llama ecosystem, so helping companies adopt Llama models directly, so seeing how Llama can be great for their use cases, which model may be the best fit for them, and also helping with some of our, what we call channel partners, so cloud providers and beyond, to folks that host our model to make sure that the model is hosted properly with rich features. So if any of you have experience or feedback or anything like that for Llama, please feel free to reach out.
Awesome. Thanks, everyone. So let's go ahead and kick off the panel discussion. So starting with you, Terrence, it seems like it was just not that many years ago now that we were talking about BERT as being a pretty large model. These days, we're talking about models with trillions of parameters. It's really changing the scale of how we think about these systems. What do you consider in your capacity, in your role, small versus large? How do you think about the motivation for choosing between a small language model and a larger foundational model? And what types of use cases come to mind for each of these types of models?
Yeah, good question. So for us, small models would be maybe 1 billion to maybe 8 billion parameters. Larger models would be 70 billion and up. Like you said, very, they can get very, very large. So choosing between them, so first of all, Llama family of models offers a wide range of models across the range of the small to large models. For smaller models, we see them as being very efficient, great for on-device applications, and very versatile for fine-tuning, because it's just very cheap to serve and fine-tune, and you don't need as much hardware. And for larger models, it's more good for out-of-the-box performance, enterprise-level applications, things like multi-modal, longer context windows. For smaller models, we have some popular ones from Llama are like Llama 3.2, 1B, 3B for more on-device mobile use cases, and 8B, one of our most popular models, very versatile for fine-tuning and that serving. For larger models, we have anything from like Llama 3.1, 405B, great for distillation and out-of-the-box expert performance. 3.370B for good conversational general model, and of course our newest and greatest Llama 4, Scout and Maverick, natively multimodal, great at multilingual use cases. And choosing between them, I think it's a little bit going back to the strength of both. So if you have more like one use case that you can fine tune, or you have more preference towards speed and don't mind spending a little bit of time tuning them, or you need on-device applications, then I would go with the small. If you just want good out-of-the-box performance, enterprise-grade performance, probably larger models will be the answer.
All right. And Pablo, you work very closely on SLMs in your role leading research teams at Nvidia. What are some of the optimizations that your teams are working on, and what are kind of the implications of this for engineers that are looking to adopt these systems?
Yep, thank you for the question. So yeah, small language models, it's quite interesting. First of all, the definition of it, right? At Nvidia, first we thought about small models like being 2 billion parameters, then it became 4, 8, and now we consider 12 billion as a small model. One of the reasons that we need to consider how these models will be deployed, right? So if you take, let's say, 8 billion model, it's a very good model to fit on 24 gigabyte GPU, right? With a long context like 1 million tokens, for example. Then we talk about models like 49 billion size. Those models will perfectly fit on H100 or A100 or B200. So we need to have a model that fits and uses full power of single GPU. And of course, then we have very large models. This we consider like 250 billion parameters. That's gonna take one node of GPUs, right? But to me personally, small language models are also exciting because we can apply them for applications like gaming, and we already have NPCs that are powered by our models. These models will be of size like 500 million to 2 billion parameters, because on GPU you will run other things like rendering, for example. In terms of optimization, we clearly see that alternative architectures are taking off. So previously mentioned Mamba. On very long context in applications like RAG, it can provide up to 5x throughput for the model by using this Mamba, and Mamba is a state space model where we have a fixed memory, right? In attention, the memory increases the more tokens we have because we need to store KV cache. But for Mamba-like models, cache size is fixed, so it's really good for long context. So yeah, I suggest to be prepared for alternative models. Another thing that what we see is the importance of instruction following and tool calling. So these small models can solve very large tasks by using MCP, using other tools. So that's what I'm also kind of excited about. I don't think the small models need to remember all the MMLU or all the medical terms, right? We need to know and teach these models how to use things. So probably these two, I mean, obviously quantization, everybody do quantization. We recently introduced NV FP4, so without much of the loss, we can run models in FP4 on our newest GPUs. Yeah. I mean, also in terms of optimization, we get all these small models via pruning and distillation. So we take large model, we take target data set, we compress the model, remove all unnecessary parameters, and do distillation to recover this task-specific performance. Yep.
Awesome. Yeah, I'm really excited to see FP4 take off the same way FP8 has in recent years. Rajneesh, over the last year or so, we've started to see the idea of pre-training your own foundation model. Early on, we had a lot of companies that were exploring this route. Start to taper off a bit. I'm seeing a lot more adoption of the best-in-class open source or proprietary models, and then particularly doing kind of post-training optimizations on top, so doing fine-tuning, doing RLHF, things like this. What do you feel for your customers is making these approaches like post-training and fine-tuning more approachable, and what are some key use cases that you're seeing emerge?
Great question. So one of the things I want to clarify is within AWS, we still see a lot of demand for pre-training. We have many of our customers, such as Luma.ai, Hippocratic.ai, including internal Amazon first-party model provider Amazon Nova. They are doing extensive pre-training. So we are building larger and larger clusters for them so that they can run their pre-training workloads. But at the same time, you're right. We have seen a lot of demand increase for fine-tuning the foundation models over the last 1 year. And there are a few reasons why that is happening. One is the choice of models. The type of models which were available earlier, high-quality models, including Llama, Mistral, and many other open-source models, earlier were not available or were not of that quality which they are available now. At the same time, many of the proprietary models are also providing fine-tuning options. So that is one reason, which is the model choice. The second reason that we see is the type of fine-tuning techniques which were available earlier versus now. These have tremendously improved compared to the previous state. For example, earlier SFT was very popular, and now other techniques such as LoRa fine-tuning, QLoRa, as well as reinforcement learning with human in the loop, as well as human reinforcement learning with LLM as a judge. These have become very, very popular, and these are very effective in different type of use cases. So this is the second reason, which is the type of fine-tuning techniques which were available now with a lot of research which has happened are far more effective. The third reason that we see is the availability of data. The type of data which was needed for the previous techniques required a lot of labeling for supervised fine-tuning, and now even that labeling load and the quality of data has reduced. So we see many of our enterprise customers as well as startup customers are using fine-tuning a lot. At the same time, the total capex needed for fine-tuning a model versus pre-training is significantly lesser, so it's far more cost-effective. So that is also another reason that we see more and more customers are using fine-tuning these days. Now, coming to the type of use cases, we see many customers using their own internal code repository and using that for fine-tuning their code recommendation models for their internal coding recommendation workloads. So that is one example. The second example that we commonly see is knowledge base or knowledge search within the enterprises, where customers are fine-tuning the models and using RAG along with it, and the performance turns out to be better. We also see quite a few use cases where even customer support, where customers are fine-tuning customer support model using a combination of RAG and various other techniques, and using this as a common way of improving performance of their applications. So there are a variety of different use cases that we are seeing from many of our customers, including our startup customers as well as enterprise customers, who are not only leveraging fine-tuning as a technique, but many other techniques, including RAG, and now MCP has become very popular, and connecting to different type of data sources. So all of it is coming together and helping customers solve these problems, which were not possible earlier, say, a year back.
Thank you. Yeah, it's really interesting to see that it's not just that there's a complete shift, but there's like an adoption of all these things taking place. Akshay, your team is building multimodal AI systems to help power food ordering. How vital is model accuracy for your use case? What role do you see fine-tuning and other post-training techniques playing in the type of use cases that you're working in?
Yeah. So when we started off, initially, like moving over to generative AI. Now, like just for some context, right? So earlier, voice AI systems were all traditional ML, right, and traditional NLU stack. So they used to be parts of a much more deterministic system, right? So when you say you want to order a pizza, you would get a pizza at the end of it. But then it comes with its own problems where it doesn't understand context, it doesn't understand how humans naturally speak, and we had a lot of problems with that. But as we moved on to generative AI systems, now that systems are like more capable of understanding context, and models are more capable of understanding what the users actually are asking for. The problem lies on translating that to a more deterministic output, right? And I think that's an important question there, and that's an important point there, that while we all obsess about the LLMs can understand everything, how do you translate that to an already existing deterministic system, right? And while it's again very easy to trivialize that problem with tool calling and say that, well, you can always do tool calling and you can have MCP servers. Real life systems are much more complicated, and like some of the examples from the DoorDash team that they were talking about like actual catalogs being so much more complicated, SKU names being much more complicated. The translation does not always sit very straightforward, right? And when we started off solving this problem initially, we started off like everyone else with like general models, prompt tuning, few shots, RAG, everything possible, right? At the end of it, in a real-time system, such as food ordering, especially like you're talking about drive-through, imagine you go to a drive-through, you very clearly say no onions, at the end you do get onions. Like you're gonna be mad at them, right? And it's, for a critical industry like that, you're just gonna make so many people unhappy. In most businesses like that, it takes 2 or 3 people to complain to really, for them to shut down your system, right? It takes that much. So accuracy is a major concern. Eventually, like we were only able to solve all of this by fine tuning, and even then, I wouldn't say we have completely solved it. We've made it good enough that there's not enough complaints coming back, and stores and like people who are actually on the ground trying to use these systems are not really suffering with it, right? So all in all, I mean, like I would say in enterprise. Real-time critical systems which require like immediate output, and they don't have the the ability to have a human sit in between and like validate something, or they don't have the ability for a larger, more expensive LLM judge to discern whether the output is correct or not. Fine-tuning is, I think, like super important. Nevertheless, there are a lot of domains where like you can have it can still be a very real-time domain, but the stakes are much lower, and you can walk away with much more simpler systems. You don't necessarily have to invest a lot in post-training, and like pretty much like general RAG techniques and like foundational models do the trick.
Awesome. Terrence, kind of as Akshay was describing, we're seeing that in these sort of performance-critical cases, fine-tuned models that are very fast and also very performant end up being a really important part of making the systems work in production. On our platform, Llama 3 8 billion, Llama 3.1 8 billion in particular is like still like the most popular model that people work with. We've seen it outperforming GPT-4 in many cases. What do you think is stopping everyone from just adopting this kind of generalized approach of fine-tuning SLMs to get like great performance and great speed? Like, what are the barriers and roadblocks that you see at a kind of individual level, but also an industry level, that need to be overcome to get to more adoption?
Yeah. First of all, great to hear that the 8 billion and I think 3 billion you mentioned are like the most popular models on Predabase. Like, definitely awesome news. In terms of barriers of like smaller models with fine tuning, I think there are a couple. The first one is we see that, first of all, like understanding that fine-tuned small models can actually beat some larger, more general purpose models, like you mentioned, 3.18B actually beating GPT-4 or other larger models is still not not very widespread. That knowledge is not very widespread. And without that knowledge, without that hunch, many developers just default over to like larger general purpose models to get started because they didn't know that with a little bit of work, with some fine tuning, they can actually get similar or even better performance and pick up all the other benefits of like speed and cost and things like that as well with the smaller models. And the second one is the tooling, I think, and that tooling goes for both fine-tuning and eval tooling. So fine-tuning today is still sometimes seen as like you need a lot of ML experience, you need GPU access, like none of these are like super easy or trivial for developers. So it's seen as like a little bit difficult for developers, especially if they're early on in their journey. And also eval. So how can developers understand that maybe a smaller fine-tuned model can actually work for their use case versus like this use case really needs larger models. And the third one is deployment. Once you went through all that work, you have a fine-tuned model now, you need to deploy it somewhere, and deploying at scale across different platforms of fine-tuning is where we still see a bit of challenge. So to the second part of your question, how can we as an industry and like help developers move past that and to realize those benefits of smaller models? So I think for that one, so first of all, we should get better at doing case studies and just developer education that, hey, with small models, with fine-tuning, with prompt optimizations, like with all of these optimizations, you can actually get or exceed the performance of larger frontier models. And also with the tooling, so develop better tooling to make fine-tuning easier, even one click, just upload your data, and make it very easy to get that GPU access and just reduce the barriers of entry. And also for evals as well, making it easier for folks to understand, okay, for this use case, a small model with fine-tuning, we can actually get there. And then thirdly, for deployment, making it easier, one-click deployments for fine-tuned models. And this kind of requires us as an ecosystem, as a community to all chip in and help developers and companies realize the benefits of those small models.
Awesome, awesome. Rajneesh, a lot of the recent innovations coming out of AWS recently have been applicable to the inference use case in particular. Like we've seen a lot of work with speculative decoding and dynamic adapter loading, similar to some of the stuff that Lorax does. Do you see that there's a blurring of the lines between what is kind of fine-tuning and what is inference? Are these things ultimately converging to solving the same set of problems? And how do you see these things, the trends here, in terms of like how they relate to one another going forward?
Yeah, we definitely see a form of convergence in a way where inference is part of the training loop. For example, if you're doing reinforcement learning and you want to have a reward model in the training loop itself is used for generating inference. At the same time, in case you are doing distillation from a teacher model to a student model, even at that time, the inference is needed. But having said that, it doesn't necessarily mean that training and inference systems are converging. Because in case there is no need of having training done at the time of inference and you require high availability, you require the SLAs which are needed for running mission critical applications, those inference systems will continue to be different. But when it comes to new techniques which are emerging, whether it is distillation or reward function based reinforcement learning, we are finding inference techniques which are otherwise needed for a dedicated inference type of applications or its infrastructure are also needed for the training systems. So that is the reason why even on AWS, we are bringing a lot of similar capabilities for customers, such as you are training these models or fine-tuning these models, you have the capabilities to generate inference as part of the training loop. And we provide a lot of optimizations and developer experience improvements on top of it. So SageMaker offers a capability called SageMaker Hyperpod recipes. And these are the recipes where you are given the defaults of various different configuration parameters. And these configuration parameters are the ones that you can use as is when you're fine-tuning a model, or you can modify these so you get started very, very quickly. And through these recipes, the underlying inference and underlying training is taken care of because we have built the training and inference infrastructure for all these specific needs.
Akshay, you're running a very high-stakes voice ordering system, requires very high uptime, availability, low latency. What are some of the biggest hurdles that you had to overcome to build a reliable inference stack? In your opinion, how do you think about the build versus buy equation of deciding whether you want to build something from scratch yourself or go with a more managed solution?
Yeah, great question there. I think there's like two parts to that answer. The high stakes part of the entire solution, right? I think one of the things that we are very tempted to do because of how amazing generative AI has been is to try and give it so much control. You want to let the model do as much as possible because our intuition says that it's going to be good at it, right? That the outputs are going to make sense and it's just going to work out. But reality is far from that. So I think for high stakes situation, I think one of the important learnings for us to increase reliability has been to find the right mix of a deterministic system and injecting generative AI and large language models, small language models, and I would also call micro language models at this point, at just the right points, right, where you want to give it control, right? So essentially, instead of building a system and you trying to teach the system what it needs to do right, you build a lot of smaller models that tell the system what it's doing wrong instead, right? So basically, inverting the level of control and letting the deterministic system drive most of it. Obviously, with different pieces of the infrastructure could have different functions there, but I think that allowed us to build a really high-stake system with the right kind of control, where we still have the determinism that is required for production-grade systems, but it still has the flexibility to understand what a language model and contextual understanding would provide, right? That's the first part of the question. The second part of build versus buy, in all honesty, and we've been experimenting with a lot of language models, trying to train our own models internally. We've used OpenAI in production as well. What we've tried to do essentially is we've tried to just build a layer of multiple fine-tuned models where if this one fails, let's go to this one. If the next one fails, let's go to the next one, right? Eventually, I think the solution is definitely buy the right one. But the solution, in my opinion, is to go away from a token-based pricing model and move towards TCO-based, right? Just buy the whole stack or own the stack so that you're not paying on a token-based metered basis, right? And I think at scale, it does help out in token-based pricing does help out in prototyping and in smaller applications, and that's where the buying part definitely helps. But the moment you start scaling out, and the moment you start seeing where your margins are getting affected, and especially for again real-time applications, and we have to understand that 6 months down the line, you will be using all these models twice as more, thrice as more than what you're using it today, right? And if you're not sort of being conscious about how you're using it and how much you're eventually going to spend on these, it will come back to you. So in the long run, for scaling and buying the stack and basically owning that stack is definitely a better choice in my opinion.
Makes sense. Yeah, definitely seen that trade-off where the token-based pricing early on, is very cost beneficial, but then once you get to scale, the unit economics completely change. Rajneesh, SageMaker and Bedrock, both two complementary projects coming out of AWS that are addressing diverse types of customer workloads for AI. What needs are you hearing most frequently from your customers that you feel are unaddressed in the market today, and how is this informing your product roadmap, particularly around inference?
Yeah. So let me start with a quick overview of Bedrock and SageMaker in case folks are not familiar. Bedrock is a service offered by AWS which provides a wide choices of foundation models, high-performing foundation models, and exposed as an API. Say, for instance, in case you want to call Anthropic or Llama or Cohere, you can just use an API to call these models and switch back and forth. And a lot of tooling on top of Bedrock is the tooling which works across all these different models. So it becomes a lot easier to experiment and go live in production. As far as SageMaker is concerned, SageMaker is a managed service for building and training foundation models, including running inference. So Bedrock also is built on top of SageMaker. It uses SageMaker behind the scenes. The key fundamental difference is what kind of controls that you would like to have. For example, in case of Bedrock, you deal with an API to get the response, whereas in case of SageMaker, you can actually manage instances and you can manage the full stack all by yourself. So we also see this kind of trend when customers go to scale. That is the time they evaluate different type of options, whether they would like to pay using token-based pricing or they would like to manage instances. So now coming to your question, specific question on inference. Customers have been asking that they want highly secure, highly performant, cost-effective inference. And we have seen in the past is earlier, say for instance, for building any type of application, you need compute, you need storage, you need databases, and now you also need inference. So we expect that any application which is going to be built in future is going to require inference, which essentially means that you need to have very highly available, highly secure inference capabilities. So that is what we are primarily focused on, which is how do we make it easier for customers to get access to highly secure inference service, either within SageMaker or Bedrock, and enable them to get the best price performance without they doing a lot of work for tuning and fine-tuning and things like that. So that is the primary focus that we have. Going forward, you're going to see most of our features which are going to be launched are going to be centered around price, performance, and security and guardrails as a theme. We have done a lot of work in the last 1 year around this dimension, and you will see quite a few launches coming on our way.
Nice. Yeah, excited to see some of those new features coming out down the road. So starting to wrap up a bit here with a couple of closing questions for folks. So Pavlo and Terrence, both of your companies are investing very heavily in open source. Where do you see the future of open source models going? Do you think it's ultimately going to be consolidated across a handful of model providers, or do you think that there's going to be this growing ecosystem of open source that will continue to proliferate? Maybe starting with you, Pavlo.
Yeah, I think open source for us is very important. Like around a year ago, we released the first reasonable open source model. It was Llama 4B. We compressed 8B to 4B around August. And as of like last week, I think Nvidia is a second largest contributor to Hugging Face. We're just behind AI2, which I think in a month or two we will be the first one. So for us, open sourcing is very important. Our strategy is take existing open source models, and we work a lot with Llama models, obviously, and add new functionality to these models. So for example, I previously mentioned about fitting models to specific GPU, or adding new things like reasoning. Llama 3 didn't have reasoning. We added reasoning, and this model became the top reasoning model in the world, this 253 billion I mentioned. We also add other capabilities like vision language, for example, models, or in future those models going to be Omni-Models. When we also talk about open source, it's not only about models, it's about software stack as well. So we open source, let's say Megatron. It's a set of kernels and frameworks to train large models with all possible parallelizations, tensor, context, pipeline parallelization. Reinforcement learning is a big scene right now, so we open sourced NeMo reinforcement learning framework. Safety is very important. We are working very religiously on Aegis, Garak, such following things. And another important aspect of open source are data sets, I feel like. So from now on, we are releasing the data sets that we use to create these nemotron models like Llama I mentioned. So people can see that at least the data we used, to be completely open. I think that's the main factor. Again, for us as NVIDIA, we are happy to take any open source model and make it even better. In terms of what I think about the rest of companies, it's a tough question because you want to be on top of the game, right? For example, I'm very excited about diffusion language models, and I don't know if you know, the Google released around 2 months ago this preview for Google diffusion model, and this model is not open sourced, right? Because they want to keep some secret. So probably in a half a year or year, we will see more such open sourced models. But I think what Meta did with Llama was really amazing. This pushes a lot research field where I'm working on and help people to build on, right? And now everybody know Llama, but not everybody know other closed models. Yep.
Awesome. And I'm very interested to see what the effect of a really strong open source diffusion model has. I think everyone's going to have to rewrite their inference servers at that point in time. Terrence, same question to you.
Yeah, first of all, thanks, Pablo, for sharing. And so for us, open source has been important for a long time. We believe that it helps to accelerate technology development. It creates these vibrant ecosystems and also helps with safety as well. So we've been investing a lot with open source, like with PyTorch, with FAIR, all those investments. When it comes to AI, it's more, we believe that, open source, open models are great. And they're great for developers, they're great for us, and they're also great for the world. So for developers, the benefits are pretty clear and obvious. You can take the model, you can train it, you can fine-tune it, distill it, do a variety of techniques specific to your use case to make the model work for you. And then once you're done with that, you can, for inference, pick what works best for you, what's the most cost-effective, and so on. For us, for Meta, the benefits are we get to benefit from that vibrant ecosystem of tools, feedback that we can then use to further improve our models and other optimizations as well. For the world, believe that open source, open models makes the benefits of AI more widely accessible, so to spread those benefits more equally. So yeah, look forward to see what you all build with our open models and Llama. So.
Awesome. Yeah, I continue to be very impressed with Meta continue to put out these state-of-the-art models for complete use in the open source. So really appreciative of that. Last question to close things out for Akshay and Pavlo. What's one hot take or prediction about the future of Gen AI for 2025? Starting with you, Akshay.
Yeah, hot take. So I think my idea of what's going to happen next is basically a little bit on the multimodal side. I think we are sort of plateauing on how good completely just solely text-driven models are getting, right? And people are already extracting that to the most. We're fine-tuning, everyone's using it's getting cost-effective, it's high on performance, it's basically doing everything that it needs to be doing, right? And there's going to be progress, obviously. But I think the next step to unlocking a lot of productivity in terms of applications in real-world usage is when image and video, basically the next domain really comes into the picture, and that's basically how humans interact. When we speak about something, we look at it and we speak about it. When we give feedback, we show that this is how you should do it, and we give feedback. And I think that is that's basically. I feel like there's still some juice to be extracted there. There's ways to better compress and there's still, I think, a few algorithms that could be optimized to make multimodal languages, and I bet you guys are working on it. Everyone's probably working on it to really make it cost effective as well. And when that comes in, I think that's gonna significantly unlock a much larger swath of generative AI applications.
Nice. And Pablo?
Yeah, I completely agree. Especially Omni-Models is definitely a hot take for this next year. Imagine we deploy these models for robots. For example, we want to speak to the robot. Then the robot also needs to imagine things, like if it solves some task, you need to plan, okay, if I do ABC, what's going to happen? Another thing that might be very hot for this next year, the diffusion models I mentioned. Because current after-aggressive models, they are bandwidth limited when we start generating things, one token at a time, but we load every entire model for a single token. But diffusion models, they generate many tokens together, so it's become compute bounded, same as prefill we are doing. So efficiency is a big thing for Nvidia, and this diffusion model can be one of these things. And finally, third one that people don't talk much in research yet, but it's going to be a hot topic. You can believe me, it's about hallucination and killing hallucinations. Imagine I'm doing deep research and I'm analyzing financial documents of the company. If my model will imagine one number and change, I don't know, billions to trillions, it's going to be a catastrophe for the entire system. So we need to think how to address these issues. And probably we should think something beyond generation, because generation is when model hallucinates. Yeah, to be short, like that. I mean, obviously I'm doing research, so I can name 10 topics.
Nice, nice. Yeah, I think the hallucination one is very interesting. I definitely feel like this could be the age of getting some good reward models as well that could potentially help with training hallucinations out of models. So excited to see where this goes. All right, well, that's all the time we had, everything we had time for today. Thanks very much for joining the panel, and thank you, everyone, to our guests on the panel today for coming up here and presenting. And I'll hand it back to you, Deb, to close things out.
Thank you, everyone, so much for the panel and everyone who joined. And unfortunately, didn't have time for any audience questions, but we are going to go ahead and have a little lunch outside. Mediterranean food, which tends to be a Predabase team favorite, is kind of right out there. If you would like to be able to intercept any of the folks that were giving talks earlier today or on the Predabase team, please feel free to. We're going to be around for at least another 45 minutes or so until 2 p.m. If you want, you could also meet us at the SWAC table for the raffle. A number of different prizes are going out. Michael's told me that very few tickets are currently in, so that the odds are extremely high, just saying. And apart from that, I just want to say, it's been a massive day for Predabase in a number of different ways, but a huge part of it is just because of the community that we're able to engage with here. So thank you again so much for making it out to DeployCon. Huge thank you to our speakers and our partners, and yeah, excited to keep going and have lunch with you right outside. Thanks, everybody.